entitled Finding the Extrema on an Interval. Extrema, I guess, is the plural of extreme. We want to find the extreme values on an interval. Okay. Now, where might this happen? If you have an interval from A to B, where might the highest and lowest values be? Well, in this, now we have to talk about whether we include the endpoint or not. If it's an open circle, that point's not there. If we fill in the circle, then that point is included. But it doesn't matter on this case because the extreme values, the max is there and the min is right there. And the max happens where the first derivative was 0. The min happens where the first derivative is 0. That's one case where you can have an extreme value. And you can have your extremist. For the record, real quickly, you can have 2 mins or 13 mins. This graph will have a few mins. This graph had a few mins. Okay? These points all happen to be the lowest. And based on this graph, it ends here and it starts there. I guess right here would be the max. And again, it happened where the first derivative was 0. The extreme value. But that's not the only place where it can happen. Again, our graph will go from A to B. Maybe the graph goes like this. We will say include this endpoint and we'll include this endpoint. Well, between A and B, that's the highest value. And right here, the lowest value. The lowest value happened where the derivative was 0. The highest one happened at an endpoint. Now, what happens if the endpoint wasn't included? What if it were an open circle? Okay, for argument's sake, let's suppose there's the y-axis, and this height right here is, say, 70. Well, what's the highest value that this graph takes on? Well, it never hit 70. Well, a lot of people would say, oh, well, then 69. Well, there are lots and lots of numbers between 69 and 70. Lots of them. There are as many numbers as 1, 2, the list 1, 2, 3, 4, 5, 6, 7, etc., as there are numbers between 69 and 70. I mean, how about 69.1? We'll call that the first number. 69.2, we can call that the second number. 69.3, we'll call that the third number between 69 and 70. And then 69.4 and 69.5. And, eventually you get up to 10. So we'll call it 69.10. And eventually you'll get to 2,345 on this list. So, how about 69.2345? There are many numbers between 69 and 70. We didn't talk about numbers like the square. Well, I don't know what 69 squared is, so scratch that. But there are many, many numbers between 69 and 70. You know what? None of that. There is no first number. There is no first number below 70. There is no first number below 70. And let me just argue that. I think all students should see that there is no first number below 70. For example, since we're talking Y's, I'll draw it vertically. Let me blow up the number line between 69 and 70. If somebody says, come on, there it is. That's the number right below 70. That's not true. You know why? If you take this number and you take 70 and you add them up and divide by 2, you'll find the number in between. And then the student goes, oh yeah, I'm sorry. That's the first number before 70. Nonsense. Because we can do this game forever. If it weren't for the fact that my market has thickness between it. If you now say, oh, come on, that's the first number before 70. Well, I'll add up those two numbers and divide by 2, and I'll find a number in between. That number is closer to 70 than the number you just gave me. This game will never end. So what's going on? This graph with the open circle right here, it has no max. And the min happens to be where the first derivative is 0. You can have, so far, you can have max and mins at endpoints. Or you can have them where the first derivative is 0. For example, if I modify this graph just a little bit, if I went like that, I included the right endpoint, then, yeah, the first derivative is 0 here, but who cares? The min is at B, at the endpoint. And notice that on both endpoints, the derivative isn't 0. It could have been, all I would have to have done is stop the graph right where the derivative is 0. I'll stop the graph right there. Right there. The derivative is 0, and it's an endpoint, and it's a max. Okay, there's one last scenario for having highest value, or an extreme, highest value or lowest value. And that's where the derivative doesn't exist. Here's A, here's B, and maybe you have a graph that goes like this. Okay? It seems to me like at A, that would be the lowest point, but it's not a point on the graph. So there is no min. But there's a max right there, where the derivative does not exist. The derivative does not exist at that corner point. Okay, so how do you find the max and min, the extreme on an interval? You have to find where the first derivative is 0. You have to find where the first derivative does not exist. And we're assuming the interval is called from A to B. You have, okay, how about we say f of the left endpoint and f of the right endpoint. Those are the only places where you can have extremes. So suppose I tell you that f of x is equal to 7x plus 5. So we take the derivative and we get 7. Now two things about this derivative. It's never 0, and it doesn't exist, because it's always 7. I mean, if somebody asks you, well, what's that prime of 4? You should say it's 7. Because when I replace 4, whenever I see 7, I get back 7. Why? There was no x. If somebody asks you what f prime of negative 7 is, it's 7. It's never 0. It's never undefined. Okay, of course I left out one thing. The instruction is find the extremas for f of x on some interval, -2 to 10. Include 10, don't include -2. So we didn't come up with any x values for the first case. We didn't come up with any x values for the second case, but the last two you always do. F of -2 is 7 times -2 plus 5, which is -14 plus 5, which is -9. And f of the other endpoint, f of 10, is 7 times 10, which is 70, plus 5. And 70 plus 5 is 75. Now, you look at all of these numbers. That's the largest, that's the smallest. 75 is a possible max, possible extremer, and -9 is a possible extremer. But we rule out the -9 because we can't let x be -2. Since we're closed, it says do not include -2. But do include 10. The f for 10, that's your max. You have a max at the x value, comma, the y value. Okay, let's try another one. How about we have this? I think this would work. Suppose f of x is equal to x cubed plus 3x squared plus 3x plus 29. And we want to find the extremes of f of x on the interval 0 to 8. Don't include 8. Well, I'm going to say 0 to 2 because I don't want to cube 8. We'll go from 0 to 2. 0 to 2. Okay, this is a 2. So now we take the derivative. F prime of x is 3x squared plus 6x plus 3. I can factor out a 3. From here, when I pull out a 3, I have x squared plus. From here, when I pull out a 3, I get 2x. 3 times 2x is 6x plus. And when I pull out the 3, I get 1. Because 3 times 1 is 3. Just like it should be. And then within the brackets, I can factor. Two numbers that multiply out to plus 1 and add up to 2. 1 and 1. So it's x plus 1 times x plus 1, or x plus 1 squared. Well, this is always well defined, that it never does not exist. Because no matter what x value I give you, you can always add 1, no matter what to it. No matter what number I give you, you can always add 1 to it. And then you can always square it. And whatever you get, you can always then go and multiply it by 3. Okay, but you know what? It can equal 0. It can equal 0 when either 3 is 0, which is never ever true, or when x plus 1 squared is 0. Well, what do you square to get 0? 0. So x plus 1 must be 0. But that implies that x is -1. And after all, if x is 1, 1 plus 1 is not 0. It's -1. Okay. So I found all the x values and made the first derivative equal to 0. But I am going to reject this one because it's not between 0 and 2. For example, possibly the highest value here. At 0, we're way up here, and at 2, we're way down here. And so maybe the graph highest. But the problem is we're only talking about from 0 to 2. We're talking about x is going from 0 to 2. So we don't care what happens at -1. We only care about what happens on our interval. If your boss asks you, for last month, for say September, what was the most money we made in a given day? And you on what day did we make the most money? And you say August 11th, that's a pretty bad answer, because your boss asked you, what was the day that we made the most money in September? And you're going and saying the answer is in August. Well, maybe August you made more money than that day in August. Maybe you made more money than any day in September. But your boss didn't ask you that. Okay, so there are no values for the first derivative equal to 0 that we have to look at. There are no values that make the first derivative equal to be undefined that we have to look at. So now we just have to look at the endpoints. You always look at the endpoints. And since I'm asking for f of a number, we're going to look at the f of f formula. And for polynomials, f of 0 is always a constant. Why is that? Because 0 cubed is 0, 3 times 0 squared is 0, 3 times 0 is 0. You add those zeros, you get 0. You add 29, you get 29. F for 2 is, this is how I'm going to write x, 2 in brackets. X cubed plus 3 times x squared plus 3 times x, plus 29 equals, this is 8, 2 cubed is 8, plus 3 times 2 squared. 3 times 2 squared. I know what 3 is. It's 3. And I know that 2 squared is 4. 3 times 4 is 12. Plus 3 times 2 is 6. Plus 29. Well, 8 plus 12 is 20. And 6 plus 29 is 35. 35 plus 20 is 55. Okay, so we came up with two numbers, 29, 55. 29 is the smallest, 55 is the largest. We are allowed to use the 29 because it happened at 0, and on our interval it says we can include 0. Okay, now f of 2, that's the highest value, that's a possible max. But since it says don't include 2, we just have a min. Okay, one last thing. What if I allowed, what if the interval were different? What if I said the interval included -1? What if I said the interval goes from -2, including -2 to 2? Well, the big thing would be is we would not try f for 0, because it's not an endpoint. We only try f for endpoints and x values in our interval that makes the derivative 0 or undefined. So the reject for -1, that's back. That is -1 is back. We need to find what f of -1 is. We need to find f of -1 and f of the endpoints. Well, f of -1 is, this is how I write x, -1 in brackets. It's x cubed plus 3 times x squared plus 3 times x plus 29. -1 cubed is -1. Positive plus 3 times -1 squared. -1 squared is 3 times 1 is 3. Plus 3 times negative 1 is negative 3. But adding a negative 3 is the same as taking away 3. So that cancels out, plus 29. Negative 1 plus 29 is 28. After 2, I'm going to put the answer there. It's 55. That way I can erase it below. I need the space. So I've just found f of and all the x values and made the first derivative equal to 0, which is right there. Now I'm doing the endpoint. We have f of 2. Now we have to do f of the left endpoint. And it's going to be negative 2 cubed plus 3 times negative 2 squared plus 3 times negative 2 plus 29. Well, that's going to be negative 8 plus 12 minus 6 plus 29. And that's going to be, I think, 27. That's going to be 27. Okay. The largest value is 55. The smallest value is 27. Okay, the question is 55. It came from 2. 55 came from 2. But we're not allowed to include 2. Okay, so there is no max. There is no max. No max. Let's talk about min. The lowest value is 27. That happens when x is negative 2. Since we're allowed to include negative 2, you have a min at x is negative 2, y is 27. So you have a min of 27 and you don't have a max. When you don't have a max, that doesn't mean the graph goes up forever. I mean, it has a fairly short graph. If we include the left endpoint but not the right, in this graph, there's no max. Okay. Find f of all the values and make the first derivative either 0 or undefined. But only find f of numbers in your interval. And then find f of the endpoint. The largest value will be the possible max, if you're allowed to include that value, and that x value, and the lowest value is the possible min. And how about this one? Right out of the book I'm looking at. F of x is equal to 3x to the 2/3, I think this is minus 2x. And this is on the closed interval negative 1 to 1. So we find the derivative. F prime of x is equal to the 3 stays. You bring down the power, the 2/3. You make the new power 1 less. 2 minus 3 is negative 1. That's the numerator, over 3. Minus the derivative of 2x, which is 2. Cleaning this up for a bit, the 3's cancel. There's 2. The x to the negative 1/3 goes in the bottom, and x to the positive 1/3 minus 2. Actually, due to space, let me write that up here. Okay. What I would do at that point is I factor out the 2. Make the numbers or make the expression simple. I would factor out the 2. We have 2 times 1 over x to 1/3 minus 1. Now within that bracket, I wanted to have a common denominator. So the 1 that I'm taking away, I'll write it down as x to the 3rd over x to the 3rd. And in subtraction, if the denominator is the same, keep it and just copy down the numerator. 1 minus 30. But please, don't forget to multiply by 2. Okay. Now, this does not exist when the denominator is 0. When the denominator is 0 is when x is equal to 0. Okay? It equals 0 when the numerator is 0, but the bottom is not. Well, 2 is never 0. So when will this be 0? 1 minus an unknown is 0. That unknown must be 1. That is, x to the third must be 1. What number or numbers, if any, when you multiply it by 3, gives you 1? And the answer is 1. X is 1. Now 1 is in our interval, so that's an okay point. And for the record, 0 is in our interval. 0 is in between -1 and 1. So we need to find f of those two values, 0 and 1, and f of the endpoints. Okay, so let's do this. F of 0, f for 0 is 3 times 0 to a power, which is always 0, minus 2 times 0. Well, if this is 0, then 3 times it is 0. And 2 times 0 is 0. 0 minus 0 is 0. Now let's find f of 1. 0 to any power is 0. 1 to any power is 1. 3 times 1 to the 2/3 minus 2 times 1. Well, 3 times 1 is 3 minus 2 times 1 is 2. 3 minus 2 is 1. Okay, now let's find f of the endpoints. Let's find f of -1. We have 3 times -1 to the 2/3 minus 2 times -1. Now, in the upper right-hand corner, let's carefully look at -1 to the 2/3 power. What this asks is the following thing. What times itself 3 times gives you -1? Well, it isn't 1, because 1 times 1 times 1, it's not 3, it's 1. It's not -1. But on the other hand, -1 times itself 3 times gives you back that number. So it's -1, which you square. And -1 squared is 1. So this is 1, and 3 times 1 is 3, plus 2 is 5. And then you go to find f of the other endpoint, f of 1. And you say, oh, I already did that one. I already have that one. So now, all we want to do is find the largest and lowest y value that we just calculated. Okay, that is, we want to find the largest and smallest values of 0, 1, and 5. Of course, 0 is the smallest, and 5 is the largest. The question is, can we include these values? The answer is always going to be yes if the intervals are close. But let's double check. We got 0 by plugging in x is 0. Since 0 is in between here, you have our min at 0, 0. X happened to also be 0, and y was 0. So in this corner up here, we'll put our answer. You have a min at the origin, 0, 0. And you have a max at x was -1 and y is 5. For the next second or two, it's a possible max. Since -1 is included in our interval, we do have our max at negative 1, 5. Find f of all values and make the first derivative 0. Find f of all values and make the first derivative undefined. You could only find f of those values where it's in between your interval. And find f of the endpoints. The largest value is the possible max. The smallest value is the possible min. Okay, let me work backwards and we'll come up with a very nice problem. Suppose I tell you that the derivative, you can actually write it up higher. Suppose I tell you the derivative of f of x happens to be x minus 3 times x plus 2. That is, it's x squared minus x minus 6. That is, I tell you that f of x is x cubed over 3 minus x squared over 2 minus 6x plus 1. And we're going to talk about on negative 1, 5. So, just make believe I gave you the top line. All I gave you so far is the very top line. And if you take the derivative of this, you will get this. Let me double. Yes, you will get that. And there's an understood 1 in front of the x. Since it's x squared, you can play the x followed by a number game times an x followed by a number game. And we need to find these two numbers. These two numbers should multiply out to negative 6, the constant. They should multiply out to the constant and add up to the number in front of x, which is negative 1. Well, negative 3 and positive 2. They multiply out to negative 6 and add up to negative 1. I mean, you can verify it. 1 times negative 6 is negative 6. 2 times negative 3 is negative 6. 3 times negative 2 is negative 6. 4 doesn't go in. 5 doesn't go in. 6 does. These numbers add up to negative 5, which is not what we want. These numbers, they add up to negative 1, and that's what we want. So in the brackets, I put positive 2 and negative 3. Alright, so this equals 0 when, well, if this times this is 0, one of them has to be 0. That happens when x is 3. 3 minus 3 is 0. And here, when x is negative 2. Now, we will keep x equals 3 because it's between negative 1 and 5. But we're going to reject negative 2 because it's not between negative 1 and 5. Negative 1, 5, I like to put 0. In between here is not negative 2. Negative 2 is right there. It's literally, honestly, not in between negative 1 and 5. It's not between there. That's why we ignore the negative 2. Okay, so now what we're going to do is we're going to find, and the derivative is never undefined. Polynomials are always defined. No matter what number you plug in for x, you can take away 3. And you can always add 2. And then you can multiply those two values together. Okay, so we're going to check f of all the values between negative 1 and 5 that made the first derivative 0. We're going to find f of all the values between negative 5, which made the first derivative undefined, which were no values. And we're going to find f of the endpoints. And since we're not including x would be 5. If f for 5 is the highest or the lowest, we ignore it. If it's the highest, there is no max. If it's the lowest, there is no min. Well, f for 3 is 3 cubed over 3 minus 3 squared over 2 plus 6 times 3 plus 1. Apparently, I'm going to need more space. Okay. 3 cubed over 3. Just like x cubed over x is x squared. 3 cubed over 3 is 3 squared, or 9, minus 9 halves. Well, that gives you, well, I'm going to need that space. Plus 18 plus 1. Well, 9 minus 9 over 2 is 9 over 2, plus 19. Let me erase some of this very quickly. Over 2 plus 19, it's the same as 19 plus 9 over 2, which is 19, 9 over 2. 3 plus a half, 3 and a half. 7 plus 5/8 is 7 and 5/8. But now, let's write this as an improper fraction. 2 times 19 is 38 plus 9 more. 47 over 2. That's 23 and a half. Okay, now we're going to find f of the endpoint. We're going to find f of 1 now. That's 1 cubed over 3 minus 1 squared over 2 minus 6 times 1 plus 1. It's a third minus a half minus 6 plus 1. Okay, a third minus a half. So let's get everything over 6. 1/3 is the same as 2 over 6. Minus. Says minus. 1/2 is 3 over 6. And for the record, minus 6 plus 1 is minus 5. Minus 5 is minus 30 over 6. Minus 5, you want to write it with 6 on the bottom. Well, this number times this number always equals the top number. Meaning 8 over 2, for example, equals 4. 2 times 4 is 8. Okay, so that number is 30. Erase this when we do that arithmetic, and we'll have our answer. That's negative 31 over 6. See if we can sneak this in. It's negative 31 over 6. A little bit below negative 5. Now let's find f for 5. This is 5 cubed over 3 minus 5 squared over 2 minus 6 times 5 plus 1. 125 over 3 minus 25 over 3, over 2, minus 30 plus 1, minus 29. Okay. So now, let's get everything over 6. If I double the top and bottom there, I get 250 over 6, minus, if I triple the top and the bottom, I get 75 over 6. And here, if I double the top and the bottom, I get minus 58. And this is going to be 175, okay, 133. It'll be 117 over 6. Now, on this, in the corner right here, I will do 6 into 117. Well, you should know it's less than 20. So 6 goes into 120 20 times. It's less than 20. Now, why am I saying that? I'm saying that because before we looked at that number, the largest number that came up was, the only numbers that came up with were 23.5 and negative 31 over 6. Well, since this number is less than 20, it's not our max or our min. It's not the highest or the lowest. So, here's our max. That's our possible max. And I guess I didn't, okay, that happened at 3, which is in the middle. It's in the middle of our interval. So we have our max at 3, 23.5. And we have our min, a possible min at 1. And since 1 is in our interval, we're done. We have a min at 1, negative 31 over 6. And there's your answers. That's how you find extrema on intervals. You find where the first derivative is 0 and only keep those values, those x values that are in your interval. Find x values where the derivative is undefined. Only keep the x values in your intervals. Find f of all those x values we just said you're going to keep. And then find f of the endpoints. And the largest f value or y value is on max if that x value was included. Now we're talking about endpoints. And the least value is your possible min. Okay, that completes this section. Good luck with it.